So what if I want to find, and my main goal is how do I find the x-intercepts, right? So what we just talked about, right? If we wanted to find the x-coordinate of the vertex, so it was good timing there, Sam. If I wanted to find that x-coordinate of the vertex, how do I do that? And of course, that's the negative b over 2a formula, which again, you guys need to be memorizing. So in this case, it would be negative 185 over 2 times negative 16. So let's go ahead and see what that's equal to. So 185, and then 2 times 16 is 32. Right? And I know the answer is going to be positive because I have 2 negatives, so I don't need to worry about that. Right? So I get 5.78. Okay. Well, we saw that doubling it was what we needed to do in order to find that x-intercept. Right? So I'm just go ahead and do that while I'm here. So 11.56, 11.5. Okay. So our x value was 5.78. And so 2 times that will equal to 11.5-ish, right? And so our intercept should be at 11.5 from what we were just talking about. We can see very clearly from the graph that it's not at 11.5, right? It's actually beyond 12. So there's something going on here, right? So it's about that idea that that doubling of the x value of the vertex only works if your y-intercept is 0. This does not have a y-intercept of 0. It has a y-intercept of 99, I believe is what it was. There. And so because this is not 0, we can no longer just double that. That math does not work anymore. So we gotta find a different way, right? For all these problems here, what if you're up on the top of a building, right? So you're 99 feet in the air already, and then you're throwing something up in the air. So this is gravity, negative 16. Right here, this represents gravity. It's pulling you back down. And then this would be your initial speed of whatever you're throwing, launching, whatever. Okay, 185 feet per second. 185 feet per second. Okay. Well, you'd want to know where that thing's going to land or how long it's going to be in the air. Okay. How many seconds does it take to hit the ground? Okay. And so we want to know that. And so how do we figure that out? Okay, we can see that it's beyond 12, but we don't know exactly what it is. It's definitely not double the x value of the vertex. Okay. So what that's going to take us into is, how do we end up solving this equation? If we make this equal to 0, okay, remember that's how we find x-intercepts. We take the y side and make it equal to 0, and we solve that. How do we solve this? That's not math that you guys should really know. You may remember some of it from Algebra 1. Maybe some of you guys would have done the last part of Algebra 1, but that's generally not somebody you wouldn't have practiced it at all in geometry, so it's probably something that's been wrong. So how do we do that? Right, that's kind of where we're headed with this. This is a really big skill for this class. Okay? It's called factoring. I told you guys we were in the middle of kind of our biggest unit right now. We're working with all these quadratics, and this skill is called factoring. Okay, this is something that's going to apply to us throughout the rest of this class. And then any math you guys want to go and do after Algebra 2, you're going to need to know how to factor. It's kind of like if you walked into Algebra 2 and you couldn't add, you'd really struggle. Okay, so this is one of these really basic skills. How do I factor something? It's going to just keep being applied over and over again. Okay? So we got some definitions we need to talk about, okay, but this is our first day of factoring. We're going to spend multiple days talking about how to factor. There's lots of different ways to factor. We're going to have lots of different tools in our tool box on how to factor things. Okay, this is the first one we're going to learn. It's the most common type. It's the most basic type of factoring. Okay, so we're going to start with this. And all the other factoring that we do is going to build off of this. So you guys understanding how to find the greatest common factor is going to let us do all the other stuff that we need to do. So, big day, okay? So what's a monomial? All right, these three terms here you guys should all know already from back in the day. You might have forgotten them, but they shouldn't be brand new. A monomial is just anything with one term. So like x is a monomial. 5x squared is also a monomial. 7 is a monomial. Okay, something that's crazy like a squared, b, c cubed is also a monomial. They all just have one term. That's what it means. A binomial has two terms, so something like x plus 2. Okay, it can be 5x squared plus x. That's a binomial. It can be ab squared minus 7. Okay, that's a binomial. So there's either adding or subtracting between two things. And then a trinomial, we were just looking at a trinomial, that negative 16, x squared, blah, blah, blah. but this is a really common trinomial, would be something like this: x squared plus 7x plus 10. Okay, or it can be something pretty weird like a squared b minus 2c plus 4d. That's a trinomial, sorry. There's three things that are separated by addition and subtraction. I'm going to define factor with you guys, okay? So that one is a noun version of it, the other one's the verb version of it, okay? So what is a factor? Okay, so a factor is something that is multiplied by another factor in order to get a product. Okay, so we would say that 2 is a factor of 10 because there's something I can multiply 2 by to get 10. 2 times 5 is 10. Okay, x is a factor of 3xy because there's something I can multiply x by in order to get 3xy. Right, x times 3y would be 3xy. Okay, I want you guys to give me factor pairs. Okay. So things that multiply to be 10 are like 2 and 5, or 1 and 10. Okay, so things that come in pairs. I would like this not to take forever and waste our time. So what are some factors of 12? Two times 6. Maybe things to put in the public chat, guys. 2 times 6. What else multiplies to be 12? 3 times 4. What else multiplies to be 12? 1 times 12. There are actually some more. All right, so good, Aiden. I was hoping somebody would bring it up. So 1.5 times 8 is 12, but we don't use decimals when we talk about factoring. No decimals, no fractions. It can only be integers. Okay, so it can only be integers means that we could also include negatives. So we could actually also say that -4 times -3, and etc. are also factors of 12. We have no decimals, no fractions when we're factoring. Only integers allowed. Okay. All right, what about 6x squared? What multiplies to be 6x squared? Just think, Jarrett, multiplies to be 6x squared. Sophia, multiplies to be 6x squared. One of my Masons, what's 6x, what multiplies to be 6? All right, Aiden, 6 times x squared. What else? Ryan, what multiplies to be 6x squared? A lot more important things that I have to talk about, guys. Let's get this done. Almost, Mason. You're losing something, though. That would not multiply to be 6x squared. Addison, multiplies to be 6x squared. Kyla, multiplies to 6x squared. Could do 1 times 6x squared, sure. What else? It's a lot more. Dion, what multiplies to be 6x squared? A lot more you guys should have thought of. All right, what about 10x squared plus 5x? What multiplies to be that? It's tricky. multiplies to be 10x squared plus 5x. Sure, Jarrett. Kind of cheating, but yeah. 1 times anything is itself, sure. Well, Maiden's backtracking, still back there. 3 times 2x squared. All right, fine. What multiplies to be 10x squared plus 5x? Ooh, Tion, there you go. No question mark needed. 5x times 2x plus 1. There's 2 more. And again, Tion, that would have been perfect for the public chat. I guess there's more than 2 more, but okay. Not quite, Aiden. You're really close. Yeah, 1x. 5 times 2x squared plus x. A couple more. I'll spend time here. Okay? So that's this idea of factoring. How do we find things that multiply to be something else? Okay, so that's what we're really going to work on today. Is this skill? How do we do that so you guys can do that faster? You guys are getting pretty stuck there. Okay? So this most common form of factoring is called the greatest common factor. And we're going to start off just talking about what a greatest common factor is. Right? We're not going to be factoring yet. Okay, so this is where we're actually going to be factoring. Okay, I want you to factor these expressions. Right now we're going to talk about how to find a GCF, a greatest common factor. Okay, so I want to go ahead and define that. What is a greatest common factor? So greatest, of course, meaning largest. Okay, and then of course it's a factor. We already defined what a factor was. That's in every term of an expression. So all of this is dealing with what we call common. Okay, so when we say common, what we don't mean by common is like basic. Like if we say, oh, that's something that's really common, like it's not rare or something like that. What we mean by common is that something that we all have, like we all have something in common like that. Like we all have in common that we are mammals. Okay, so that would be something that we would have in common. So a trait that all the members of that group share. Right. So here we're talking about terms and expressions. Okay. Or if I want to think about what's the greatest common factor of these two numbers. Okay? I'm going to show you guys a method of doing this, which may seem really complicated right now, but it's really useful for stuff we're going to do later. Okay, and it's called the SOC method of factoring. You guys have probably done factor trees before, but what I want to do is look for prime factors that go into 12. Okay, I want to find prime numbers that go into 12, and I always want to find the smallest one I can and put it on the left side. Okay, so prime number that goes in 12 is 2, and that's 2 times 6. Okay. Now 6 is not prime, so I need to keep breaking that up. So I'm going to take that 6, I'm going to break it into its smallest prime, which the smallest number that comes out of 6 is also 2, and then that'd be 2 times 3. Now 3 is prime, so that means I'm done. And the 12 and the 6 got broken apart, so they're gone. So why this is called the SOC method? Because the numbers we need are there in that little sock shape. Okay? So 12 equals 2 times 2 times 3. So there's the prime factorization of 12. Okay, I'm going to do the same thing with 18. I always look for the smallest number I can get out of 18 and put it on the left. 2 times 9 is 18. 9 is not prime. 9 is 3 times 3. Now 3 is a prime number. Okay, again, the 18 and the 9 got broken apart. They're gone. So 18 equals 2 times 3 times 3. So now that I have them factored, I want to look for what's common in them. So they both have a 2 and they both have a 3. Okay? So 2 times 3 is 6, and 6 is the GCF. 2 Okay? So we break them down into their primes, and then we do this. Right? Later on, you guys won't need to do this anymore because you'll just, like right now, you haven't played with numbers like this in this method in this way in a while, so your brains aren't ready for it. But later on, you won't need to do this anymore because you'll just start to see the connections. You'll see the numbers faster. Okay, it'll just happen in your head. So right now we're doing it really in a concrete way. Later on, you'll be able to do it in an abstract way, which means it's all going to be in your head. Okay? So I want to take 36. I want to break it down. Okay? The smallest number that goes into 36 is 2. 2 times what is 36? And if you're not sure about this, you should be getting your calculator out and saying 36 divided by 2 is 18. Okay. 18 is not prime, so I need to break 18 down. Okay. 2 goes in 18 how many times? 9. 9 is not prime, so we need to break 9 down. And 9 goes from 3 and 3. Okay. So again, anything that got broken is gone. So 36 equals 2 times 2 times 3 times 3. I'm going to do the same thing with my 60. Sorry, I need to put that too close here. 60, it's 2 times what? 30. 30 is not prime. 2 goes into 30 how many times? 15. 15 is not prime. 15 is 3 times 5, right? So those are all prime numbers. Those are gone. So 60 equals 2 times 2 times 3 times 5. Then I go looking for what's common. They both have a 2. They both have a 2. And they both have a 3. So 2 times 2 times 3. 4 times 3 is 12. So 12 is the greatest common factor of 36 and 60. Okay? The bigger the numbers get, the more complex it is to figure it out. Like if I say, hey, what's the greatest common factor of 24 and 70? It might get really tricky to figure that out. Okay? So this is a method for dealing with numbers that you can't just see. And then again, once you start to see them, I don't need you doing this. Okay? So, but here's a way to figure it out. Okay, it's called the SOC method of factoring. Right? This is something we're actually going to come back to multiple times throughout the year for other things we're going to do. So I really like it versus the like just kind of a random factor tree. So something I learned quite a few years ago, and I have not gone back to factor trees in the way that I learned. Like I learned of just regular old factor trees when I was a kid, and I think this is a much better method. Okay. Do that same thing. We're going to start throwing variables at it. Okay. So now I'm going to find the GCF of these terms, right? These expressions. Okay. And so start off again with pretty simple ones. So 4x squared y cubed, and then 9x cubed y squared. So just think about it in pieces, right? Don't try to think about it all at once. I want to think about what multiplies to be 4x squared y cubed. Okay, so I'm just going to look at the pieces, right? So I'm going to look at the 4 first. Where does 4 come from? All right, again, we're starting off with the easy ones, 2 times 2. Okay. Well, what does x squared mean? What does x squared mean? X times x. This would not be a parabola because this is not a function, Aiden. And this is not something that we're trying to graph. It's not like y equals 4x squared, y cubed, which wouldn't make sense anyways because we have y on both sides. Yeah, completely different context, right? So, and then what's y cubed mean? Y cubed, not y, yeah, y times y times y, there you go. So 3 y's, right? And so in the same way, right, 9, of course, is 3 times 3, and x cubed is x times x times x, and then y squared is y times y, okay? So I've broken it all down into its primes, and we see that the variables are pretty easy to break down, right? It can be kind of tedious writing out a bunch of x's and y's, but it's easy to do it. And then we go looking for things that are in common, right? So do they have any numbers in common? Nope, no numbers in common. But they do both have an x, right, Kyla? Yeah. We both have two x's. They both have a y and a y. Okay? And so what's the GCF? Right? So x times x times y times y. X times x is x squared. Y times y is y squared. So x squared, y squared is the GCF. Okay. Let's try that again. All right, so how would we factor 6x squared y to the fifth? How do we break it down? 6x squared y to the fifth. Two times three, okay. And then what? Two x's and five y's, right? Easier way to say it, two x's, five y's. Okay. Now maybe 12 is a little bit harder to break down, right? So you can always run a sock on it. Okay. So I take the smallest number I can, which is 2 times 6, and then 6 is 2 times 3. Okay. So there's nothing stopping me from saying, okay, let's break that 12 down in a way that I know how. Okay. So that's 2 times 3, 1x, 4 y's. Okay. Once we have it all broken apart, what do we do next? See what's in common? Okay, Kyle. So both have 2, both have 3, both have an x, and 1, 2, 3, 4 y's. So 2 times 3 times x, and 1, 2, 3, 4 y's. So we get 6x, y, 4. I'd like to see if you guys notice a pattern from where we started to what the GCF was. Faster way to do this in regards to the variables. You guys notice a pattern, a faster way to do this in regards to the variables. You should be able to do a problem like this actually really easily. It may seem complicated. If I said what's x to the 7th, y cubed, z squared, and then I want to find the GCF of x to the 5th, y to the 4th, z cubed. You guys actually should be able to tell me the GCF of those two things actually really easily. So I'm looking where we started and what the GCF is. Where we started, what the GCF is. You guys notice a pattern in regards to the variables? Shouldn't have just numbers, Jared. We need to have x's and y's and z's in our GCF. Where we started, what the GCF was. Where we started, what the GCF was. pattern you might notice with the variables.
Wait, so we're looking for the GCF of x to the seventh, like the red down there?
I'm saying you should be able to do that really quickly. I want you to identify the pattern name.
Yeah.
We'd go from here to here.
It would just be it would be x 5, y 3, and like z 2, right?
So yes, I just don't like the way you said that, but yes. Yeah, x to the fifth,
I don't know.
x to the fifth, y to the third, y,
Okay.
x to z squared. Yeah. So how'd you do that?
All right.
How'd you know it? What was it?
Because I just took a smaller number out of the two of those, really.
Right, yep.
I mean,
So the smallest, what do we call those numbers?
exponent.
Yeah. So the smallest exponent is the one that matters. Okay. This one has 2 x's. This one has 3 x's. There's 2 x's here. This one has 3 y's. This one has 2 y's. There's 2 y's here. Smaller one is left here. Okay. 2 x's, 1 x, 1 x here. 5 y's, 4 y's. There's 4 y's here. Smaller exponent is the one that's in control. 7 x's, 5 x's, 5 x's. 3 y's, 4 y's, 3 y's. 2 z's, 3 z's, 2 z's here. Okay. So what if there's nothing, right? What if I had like a squared here, and I said, hey, what's the GCF now? Okay. Well, 2 a's and then no a's. Well, no a's is less than 2 a's, so then there'd still be no a's here. Okay. So the smallest one is the one that matters as far as the variables go. So you should be able to do GCFs with variables very quickly. Okay. So oddly enough, the variables are easier than the numbers. Okay. You guys make sense? Thanks, Aiden. All right. So let's actually talk about how to factor. Right. So this is just pre-thinking here, what we were just doing. How do we actually factor? Okay. And this is a big thing, right? So factoring by GCF, greatest common factor factoring, is the most basic type of factoring. Again, you're always going to learn multiple types of factoring, and this is always the one that you try first. Now you just check to see if you can. Doesn't mean you're going to be able to do it every time, but you just always check because it's really fast, and if you can do it, it makes everything else easier. Okay, so you always try it first. Okay, and I also think that this is a really important idea. You guys think of factoring as undistribution. Okay? So right now, this problem that's up here at the top, this 4x times 7x minus 5, is a distribution problem. Right? If I gave you that and I said simplify this, you should know what to do. Okay? You would then make that expression simpler. Okay? Factoring would undo that. That means that factoring does not simplify things. Factoring is not a way to make something simpler. It's actually a way of breaking it apart, making it more complex. But we need to be able to do that in order to see where stuff came from. Okay, so factoring is not a way of simplifying something. Okay? So if we think about what 4x times 7x minus 5 is, right? 4x times 4x is 28x squared, and 4x times 5 would be negative 20x. Okay, factoring would go that way. So if I asked you what multiplies to be this, we would need to undistribute. We would need to figure out what was distributed to make this, right? What do these have in common? 28 and 20 both have a 4 in them, right? And x squared and x, this one only has 1. Right? That one rules. Both have 1x in them. So I would take that 4x out. Okay. Well, what did that 4x multiply by? Right? 4x times what is 28x squared? Well, 4 times 7 is 28, and x times x is x squared. So I would need a 7 and then x to get 28x squared. Right? And then 4x times what is negative 20x? Well, 4x times negative 5 would be negative 20, and the x would already be there. Okay, so that we'd be going that way. Okay, now we got to watch out because there's other factorizations too. Remember I was asking you guys, how do you factor these things, right? And there's multiple answers to those things. There are other things I could multiply together to get what we just got. Like 2x goes into 28x squared and 20x. Well, 2x times 14x is 28x squared, and 2x times negative 10 is negative 20x. So this is also a factorization of that. But this is incorrect. Okay? When we ask you guys to factor, we want you to factor completely, which means that everything has to be broken out that can be. Okay? And so I know that this is incorrect because when I look inside, they still have something in common. 14 and 10 still have a common factor of 2. So I'm missing a 2 that should be out here. So this is not factored completely, which means it's not done correctly. It is a factorization, but it's not the complete factorization. That means it's not right. Okay? 7x and 5 do not have anything in common. So this is the complete factorization of this. Okay? So that's the way it needs to be for what we're doing. Okay? So just because you got a factorization does not mean you got the complete factorization. So you need to watch out for that. Okay? So the first thing we're going to do when you're asked to factor, okay, is you need to find the GCF of the terms that you're looking at. Okay? So I need to look at the two terms and say, what do they have in common? So what's the GCF going to be here? What do 12 and negative 18 have in common? What number goes into both?
6.
6, okay. And then when we look at the variables, x squared and x, what's going to be common there?
X.
Okay, so there's our GCF. Where does the GCF go? Okay, the GCF always goes on the outside. You're going to hear me say this a lot. Factor out. Okay, I say that word very specifically because that GCF goes on the outside of the parentheses. All right, and it's our job to then figure out what's on the inside of the parentheses. And the thinking you guys need to be doing in order to answer that question is say 6x times what is 12x squared? Okay, and then 6x times what is negative 18x. Okay, so when we answer those two questions, that's what goes here and here. So 6x times what is 12x squared? What do you multiply 6x by in order to get 12x squared? X, yeah. Yeah. 6 times 2 is 12. X times x is x squared. So yeah, I would need a 2 and an x. 2x. 6x times what is negative 18x? Negative 3, right in? And Aiden, hello chat. There. So 6 times negative 3 is at negative 18. And I already have an x, so I don't need any more x's. So minus 3. Fix this. Okay. The next thing I check to see is, did I completely factor it? All right, did I factor it or did I completely factor it? Do these two things still have anything in common? Do 2 and 3 have any common factors? No, right? All right, this one has an x, but this one doesn't, right? So there's nothing left in common here. So that means I took out everything I could. And the last thing I should check is, did I do it right? So by redistributing, 6 times 2 is 12. X times x is x squared. 6 times negative 3 is negative 18. And then I have an x. So then I'm good to go. So this is my factorization of that. So these two things should be equal to each other. Okay? We are not changing anything. We're not solving for anything. All we're doing is rewriting. Okay? Those two things need to be equal. If these two things don't multiply back together to give you this, then you didn't do it. Okay? Our job is to take that 12x squared minus 18x and break it down into where it came from. So those pieces need to be able to get me back to where I started. Okay? If they don't, then you're not doing it. They have to be equal to each other. Okay? Let's try that again. So we start by trying to figure out what the GCF is. Again, I would have you guys look at in pieces. Okay? Look at the numbers first. Okay? Look at the variables next. In pieces. So I'm looking at integer. This one has a little bit of a trick though. Okay? So if the first term is negative, you have to factor out a negative. Okay? So as we look at the GCF here between these two things, I look at that 5 and that 25. Because it's a negative 5, I have to take out a negative whatever. Okay? So what's common between 5 and 25? Remember, it goes into both. Yeah, 5, right? And so notice how I didn't even mention the negative. I just worried about the number, and I just knew my answer would be negative. Okay? So I'm just looking at the numbers, 5 and 25, and I say, well, I have a negative, so I'm just going to keep that negative on there. Okay? And then I look at the x's. How many x's should I have in my GCF? 1, right, Aiden? Yep, right. Sam, right, Kyle? And how many y's should we have in our GCF? Yep, 1. Okay, so there's our GCF, right? And that goes on the outside. And then we have to figure out what's on the inside. And again, the questions you're asking yourself there, right? So negative 5xy times what is negative 5x squared y? Right, and then negative 5xy times what is 25xy? And again, you guys don't need to write those down. That's just the thinking you should do. It helps you to do the thinking by writing it down. Then do that. If you're a really, really concrete thinker, the more you write down, the better off you are. Right? But you really will be best off the more you guys can do in your head. Right? You're talking to yourself. You're asking yourself questions in your head. If you can make this process abstract, it's going to be so much faster. And we don't want you bogged down in this stuff. Okay? So as I think my way through it, I'm just going to be pointing at stuff. So negative 5 and negative 5. I don't need anything there. Right? But here I have 2 x's, and here I only have 1, which means I need 1 more x. And here I have 1 y, and here I have 1 y, which means I don't need any more y's. Okay? So all I needed was 1 more x. Negative 5xy times x would be negative 5x squared y. 25 and negative 5. What would I need to multiply negative 5 by in order to get positive 25? I'd have to multiply by negative 5. 1x here. I've got 1x here. I don't need any more x's. I have 3 y's here, and I have 1 y here, missing 2 y's. Good one. 5 y squared. So again, just kind of checking that. Negative 5y squared times negative 5x y. Right? Positive 25. I have 1x, and I'd have 3 y's, which is what this is. Okay. Then I go back and I see if the inside there's anything left in common. X and negative 5y squared. There's no numbers here. No numbers in common. This has an x. This has no x's. This has y's. This has no y's. Nothing left in common. Okay. Make sure you pull out everything you can. Right? That first term is negative, you've got to pull out a negative. Okay? And these two things better equal this thing. Okay? All right, so you guys have a worksheet in your I want to keep factoring by GCF, so I want to look at the two terms and see what they have in common. So 3 and 25 do not share any common numbers. The first term has an A, but the second term does not have any A's. The first term has 3 B's, but the second term only has 1 B. So there's your only thing that's in common between these two things. It's going to be that 1 B. I need to figure out what to multiply that 1 B by in order to get this. Right? So 1 B times what is 3AB cubed? So look at that, there's a 1 here. 1 times 3 would be 3, so I need a 3. I have an A here, but no A's here, so I'm going to need an A to multiply by. And then I have 3 B's here, and I only have 1 here, which means I need 2 more B's. And I want to look at 25B. So 1 times positive 25 would be 25. So plus 25. And then I have 1B here and 1B here, so I don't need more B's. So that would be all I would need. Go ahead and check to see if I did it all. So do they have anything in common? So 3 and 25 have nothing in common. This one has variables, but this one doesn't. So there's nothing in common here. Let me just kind of double check to see if I distributed it right. If I distribute it, would I get it back? So B times this, I get B cubed here, 3AB cubed, which is what that says. B times 25 would be 25B. So it looks like the right factorization. A little bit more complex here. We have 3 terms now, and so I want to start with pieces. So I'm going to look at the numbers first. Then I'll look at the x's. Then I'll look at the y's. Okay? So I want to ask myself, what do 4, negative 12, and 8 all have in common? So 4 goes into 4. 4 also goes into 12, and 4 also goes into 8. That's the biggest number that I can get out of all those. And then this has 2 x's, this has 3 x's, this one has 2. So the most I can get out of 4 is 2. And then first term has 2 y's, second term has 1 y, third term has 3 y's. So the smallest amount there is 1, so that rules. So there's my GCF. So I want to figure out what I need to multiply by to get each term. So 4 times 1 is 4, so I don't need anything there. I have 2 x's in both places, so I don't need any more x's, but I am missing 1 y. So I need a y. Multiply by that. 4 times what is negative 12? Negative 3. X squared, I'm missing 1 x. I need 1 more x, and the same number of y's. So all I need is 1 more x there. And the last term, so 4 times positive 2 would be 8, plus 2, and x squared. So the same number of x's, y and y cubed, I need 2 more y's. So 2y squared. Okay, so then I want to check to see if I can do the complete factorization, so look for anything that's common still. This has a y and this has a y, but that doesn't. So they don't all have a y. There's a 1, a 3, and a 2 here. 1, 3, and 2 do not share any common factors besides 1. So we did everything we could. All right, and the last one. So remember the trick for if that first term is negative, we've got to take out a negative factor. So I want to think about negative 6 and negative 12. What number both goes in both of those? It's negative, no matter what it is, because negative first term. And what goes in 6 and 12? Well, 6 goes in both 6 and 12. And I want to think about the x's, and then I'll think about the y's. So I have 2 x's, 1 x. That means I need 1 x here. 5 y's and 4 y's, which means I need to have 4 y's. We always take the least. So 1x and 4 y's. And what's going to be on the inside? So negative 6 and negative 6. So those are the same. I do need 1 more x, and I need 1 more y. So 1x, 1 y. And then here, negative 6 times what is negative 12? That becomes positive 2. And I have 1x, 1x, 1y, 4y's, and 4y's. So I don't need any more variables. That's it. Is there anything in common here? X, y, and 2 do not have anything in common. So I should be good to go. There's my factorization.